In this tutorial, we're going to look at how we define glazing in the Zebra model. The glazing input sheet is a little more complicated than some of the other inputs for the building fabric. This is because, as well as being a source of heat loss, the glazing is also a source of energy gain through solar irradiation. As well as that, we have to account for the difference in U values between the glass itself and the framing material. This is what the glazing sheet looks like in the model. At the top of this sheet, we have an option to define the U value for the glazing. This will dictate how much heat we lose through the window. And also the G value, which is about how much sunlight will get through the glass. We have some sensible defaults for different types of glazing here. And once we've done that, we can scroll down to input the windows themselves. So we can define up to 15 window sets, and each window set can have a number of windows. So typically a window set will be a particular facade of a building. For each window set, we have to define the orientation relative to north. And we can start putting in windows. Now for each window, we need to define a number of properties. The first four are defining really the geometry of the window. Next three are the shading, and the last one is the number of windows. So we're first going to talk about how we define the geometry of the window. So for each window, we have to define the area of the glazing itself. Now that will dictate how much area we need to use the glazing U value when it comes to heat losses. And it will also dictate how much area we have for sunlight to pass through. We have to define the area of the frame. This will be used to determine the area to use the frame U value when it comes to heat losses. We also have to define the perimeter length around the window and the length of the window frame and any dividers that the window has. These two are used because there will be thermal bridges where the glass meets the frame, and there will also be a thermal bridge around the perimeter of the window, and these need to be accounted for. So we have a couple of tools to help us calculate these four geometric properties. We can either use a general tool if we have fairly detailed information about the window, or we can use a simplified version if we're an early stage of design and we don't really know much about it. So I'll look first at the general tool. So with this tool, we can define the hole width as the window hole width, the window hole height, the width of the window frame, and the width of any dividers that the window has, the number of horizontal and the number of vertical dividers. And given those inputs, it will calculate those four properties. We can then copy and paste that back into our glazing tab. Alternatively, if we don't have much information about the window, we can use the simpler version. This allows us to just choose a similar looking window from these photographs. And if we select the most similar looking window, and we type in the whole area for the window, then it will give us these geometric properties which are typical for that type of window. And again, we can just copy and paste this in to our inputs. So that's how you define these geometric properties for the window. We're now going to go into how we look at the shading of the window. First we'll look at the permanent shading, which is the shading from hills, buildings, things like that. We have a tool to help us calculate the permanent shading based on the fraction of visible sky a window has. So basically you're going to input in here the vertical angle in terms of what the window can see, and the horizontal angle. And from that, the tool will calculate the permanent shading that you should apply. And we can just copy that into our tab. Temporary shading is provided by things like roller blinds. And we can just type a level of shading into either of these, which will be applied on top of the permanent shading. So this is the temporary shading when heating, and this is the temporary shading from cooling. The last column is just the number of those windows that we have. Once you've defined window sets, you'll see a summary here, which will go through all the details of these windows. If we increase the complexity level to the glazing tab, we'll find a number of inputs are added. And you can see here the values that are being assumed when you're at a lower complexity level. So there's an assumed value for the frame's U value, the thermal bridge at the perimeter, the thermal bridge at the window frame and the window frame dividers. There's also an assumed maintenance factor. This is basically how clean the window is and affects how much sunlight will get through it. And then we have a non-perpendicular radiation factor. So at higher complexity levels, you can override these default values. So that's a run through how we define glazing in the Zebra model. In the next tutorial, we're going to look at how we define air and ventilation.